next slide. So in early 2019, Indigo purchased a company called Thales Labs. This was a company that essentially specialized in geospatial mapping and engineering. And with that acquisition, we had to take all of their infrastructure and all of our growing infrastructure as a software company that had just put out its first public-facing application in July of 2018. And not only do you have the ability to merge these, not only do you have the responsibility to be able to merge these two parts of infrastructure, but now you have to make sure that as you grow, you don't run into the massive chaos that can happen when you do mergers like this. We've learned a lot in the past year, and this is why we're here to share with you. So in a small prologue, there's a classic scenario of architecture applications being fixed and rarely iterated on, large releases for the sake of compliance or feature releases, which are big and scary, which, depending on who you ask, kind of ends up looking like the picture to the right. Although I must condone them. They do have some form of cooling system on the bottom right-hand corner. So I guess all is not lost here in this IT closet. But I guess when it comes to now, we run quick iterations on our infrastructure. We have the ability to create this idea of continuous integration. Version control systems are much more accessible. GitHub is free, and now all of a sudden we have free private repos and things along those lines. We also have the hybrid cloud with multiple different services changing as fast as the customers need, which runs us into a lot of problems. Gives us a lot of tools to choose from. Infrastructure over time needs some form of documentation. If you want something scalable, it has to be repeatable. And not everyone knows what shiny button to click. I was just recently at reInvent, in which AWS released 25 different products, specifically within the machine learning section of their services alone. So those are all different parts of infrastructure that if we want to go and experiment with, it's totally fine. But we want to make sure that we have repeatable processes and things along those lines. Otherwise, if you don't do that, you end up with something that basically ends up looking like this, in which it's the exact same chaos, but now the chaos is in the cloud. But then along comes Terraform. And Terraform is a platform that uses infrastructure as code to allow its users to be able to manage cloud and local architecture. The community version is open source, with the available enterprise version through HashiCorp. It works to create reproducible environments, idempotence and convergence through state, ease and collaboration. And it really the reason why we went with it is because it really took away the need to master the learning curve that comes with learning all of these different services and the multiple different APIs that come with these services in order to somehow create some form of automation that is reproducible for users. It can be compared to, or you might have heard these other buzzwords out in the cloud world. It's not CloudFormation. CloudFormation is much more modular. And while AWS has put a lot of work into making sure that it's a more usable tool, it's actually one of the more usable tools on the AWS platform. It doesn't actually handle any true logic. There are a few hacks that they do around the actual handling of logic portion of things. Vagrant is just another service within the HashiCorp platform. Terraform can create Vagrant resources. Vagrant is made specifically for the more fine-grained portions of virtual machines and things along those lines. Packer is another one that does just about the same thing. Puppet, Chef, and Ansible are not entirely cloud native. So in today's talk, I really wanted to make sure that I wasn't entirely sure of my audience, so I think today's talk is really going to be around having people to be able to learn something, whether it's at the Terraform level, whether it's at the HCL level, whether it's at the what can we do with this level, or the real deep dive into the actual fine grain of Terraform. So we're going to do a deeper dive into Terraform's true power. We'll cover some of the key concepts. We'll go over the AWS provider. We'll do a little more of a deep dive into AWS itself. And then we'll cover some advanced topics. And by the end of this talk, with the source code that I've given for this talk, there is, if you clone this repo down and you are to run it, if you are to run a Terraform apply, you will be able to have a full-on Terraform CI pipeline in which you can actually start using Terraform within a code build environment, within your own AWS environments, to really start unlocking the power and really start those CI concepts when it comes to infrastructure as code. So let's take a tiny step back from the words that I said a little bit ago. And the big thing that really comes from it is there's no need for the learning curve that comes with the different services in their APIs. Which brings us to the different nuts and bolts in the cloud. And this is where we really start with this is square one of Terraform. Terraform at the core is runs off of the block of resources. All other tooling within Terraform is built around the ability to manage these specific resources. So as we can see on the right here, we have defined a resource. The resource type is the AWS S3 bucket. JRice TF state will be how we reference this specific resource. And the S3 bucket takes a certain amount of arguments to be able to roll out this specific resource. Today we're going to be playing with the AWS provider, which is responsible for writing and understanding the API interactions. Commonly written in Go. That was also a really fun thing that we got to do at Indigo and start creating our own providers and really experimenting with the Go language, which has become more and more popular in the Boston area and the dev community alone. It can be compared to as a wrapper. I come from the development space where an AWS provider has many different tools within it, and from that provider, we're able to use all of the tools that come with it. And yeah, sure enough, the AWS provider is what we'll be using today. We'll get into a little bit more modules later, but it is worth noting that modules are reusable configurations that can be used throughout Terraform. A module can consist of multiple related resources, and that'll start making more sense as we go along. Variables, sure enough, my dev background gets excited about stuff like this, where we have variables which allow the inputs to a given module to be able to make their resources and parameters more dynamic. It is declared in HCL, which is the HashiCorp language, which is a little more specific, and it is strongly typed for those people out there dealing in the ever so popular JavaScript platform. This is a very cool concept that we're able to do while also taking those concepts and applying them to infrastructure. So for a really quick quiz, you want to start experimenting with Terraform, but with something smaller and with less expensive resources, such as AWS, like what we're going to be experimenting with now. You go and look for one of Terraform's many A, providers, B, resources, C, services, or D, look for a Terraform employee. Getting some B's. getting some Bs. What we're actually going to be looking at is the actual. Oops. We're actually going to be looking at Terraform providers. These Terraform providers are the ability to take all of these different types of resources that are throughout the platform or throughout the provider, and Kubernetes has a specific provider, GitHub has a specific provider, and sure enough, today we're going to be dealing with the AWS provider. You pitch this new idea to your boss of using Terraform. She asks you to name the two major benefits of using Terraform. Which of the following are the two benefits of Terraform? A, configurations are written in YAML or YML, and everyone loves YAML. It allows versioning of resources through the use of state. It provides documentation for all services and their APIs. Or it is one singular language that can be used to configure resources from multiple different providers. Sure enough, the answer is B and D. Terraform uses a strongly typed language paired with a number of different providers to handle their configuration and versions in state. Versions their state over time through state. She then replies, that sounds great, but how much does it cost? What is your best answer to this question? A, Terraform community version is well supported, documented, and free. You only pay for the underlying resources you create with it. B, it's holiday season. Is cost really a concern? Or C, as we say up in the New England area, wicked expensive. So it should be easy. The answer is A. Terraform community version is free, is well documented, and carries no cost. You only pay for the resources you create while you use it. It's another really awesome thing that really makes some IT managers happy. So sure enough, let's build. We're going to make a VPC. We're going to code up a VPC. We're going to make that VPC. We will make subnets within that VPC. We'll talk about state and making it remote. We'll dive into a little bit more of the HashiCorp language, other TF concepts. We'll start using loops for maximum power. Yes, I said loops. Using Terraform and continuous integration, which is the power of using this repo that I've given you all today. And we're going to talk about the beyond. Terraform right now is in current version 0.12.18. We're going to be using 12.14. There are some features that are absolutely fantastic, and there are some features that aren't all the way built out, but I'm really excited to see what the community and HashiCorp have to deliver us. Just for starters, every Terraform project should begin with a provider, and each provider has its own set of resources that it is capable of managing. So sure enough, and this is the repo within TF Talk. We're able to just do the dropdown of unsolved, in which we will take, and I've tried to do live coding demos before, and I just like having a small safety net in order to do JBrice default VPC2. So above here, we provided the provider AWS. Anything over version 2 in our default region will be US, let's go west, 1. This VPC will be called JBrice default VPC2 with a setter block of 10.0.0/16. So this is where we really start unlocking Terraform's power. Over here on the left, we are going to go into 01, which is our lab. We will go into unsolved, which is where our main.tf is. And this is where we will be creating our resources. Within our unsolved folder, I have aliased Terraform to be just TF. But sure enough, if we run Terraform, init. So Terraform init will go and pull down all of the necessary things within the AWS provider. The AWS provider has been created, and sure enough, over here in the .terraform folder, we have a lock.json. For those familiar with the node infrastructure with the node runtime, works a lot like the node modules folder. And so now we're able to use everything within this provider. Since we've created a resource, we are going to run Terraform plan. And Terraform plan actually shows us exactly what it is going to do when we actually go and run the next command. And sure enough, Terraform is telling us that when I go and run a Terraform apply, I will be getting a brand new AWS VPC with the CIDR block that I have defined. It will go and it will do all of the other it will go and do all the other things for me. And sure enough, when I run Terraform apply, Terraform will take the plan that I have specified above. Terraform says I'm going to go create this resource. I can hit yes. For those of you that work in automation, yes, there is the ability to skip the yes parameter. And actually, we can go watch it be created. US West 1 is Northern California. Sure enough, I don't have any code builds yet, but if I go into VPCs, I will see that a VPC has in fact been created, and that I have my default CIDR block. And we are ready to go. So sure enough, if we go back here a little bit, we'll notice that I ran Terraform init, which pulled down all the provider necessary to be able to run the resources. We ran Terraform plan, which took the plan that I had provided within the main.tf and created the things with Terraform apply. Now this is all well and good, and that Terraform will now be able to, Terraform went and created these resources, but one of the really cool parts about Terraform is that it's going to oversee the state of this particular VPC, such that we can actually figure out and track the different iterations that we have within Terraform. And the way that we do that, while I'm aware that HashiCorp does have their own hosted platform, they've actually done a really nice job for people that work in infrastructure to be able to just use S3 to hold this specific state file. So if we go into, sure enough, I've added a new resource. If I go to TF plan, to the point, I have Terraform. Terraform is aliased within iTerm2 right now. Sure enough, it tells us that it will go and add a new resource bucket. Excuse me, it will go add an S3 bucket as a resource. And once we see that, and we're totally okay with what it's going to be able to do, we run Terraform apply. And to those people that work in automation, I would just run TF apply auto approve. So let's take a step back. This is creating the bucket that we will be able to, whoops. There's probably a leak. And since buckets are completely globally unique, now we have Justin's test bucket too. You can in fact go into the services of S3 and verify that that bucket has been created in our Northern California region. And sure enough, we have Justin's test bucket 2, which I went and created here. Cool. So now we will be able to, so now that we have this resource, we're able to store that TF state file within this resource. Since now we are able to do that, we can then go into our deploy file. And now what I want to bring out is this type of block that we haven't seen before called Terraform, which is actually the ability for us to put our state file directly within this, take our state file and store it directly within this S3 bucket. And right now we will create a key called development /TF state. Since we haven't quite done that with this resource, what we want to be able to do is we will upload, add a file, we go to documents, and we will go to today's talk, the lab. We're going to upload these two specific things. We're going to upload our TF state and our TF backup to this folder. We're going to create a folder called development. Per se, maybe we wanted multiple environments to be able to put these into. And the slight downside of S3 is, sure enough, we have to be able to we're just going to keep it there. Now we're going to use that actual Terraform state file directly within when we start using this. So if we go into here and we run Terraform init, oh, we need the role. All right, let's be more efficient. Cool. So we're just going to walk through the solve stuff. There's actually a little more overall architecture that we have to do here. But rest assured, when people go and actually download this specific repo, we have a full-on ready to go portion here. So we have in this repo, we have a Terraform bucket. This Terraform bucket is actually called our TF state. And sure enough, if we do TF init, I'm unsure why I'm getting locked out of here. Terraform has kicked me out. Apologies. I'm just gonna have to walk through what we got. Using collaboration, that's what we are able to do specifically within having that Terraform state file be accessible through the S3 bucket. I guess the good news is that we can actually take that TF state file and lock it down pretty hard, such that only certain developers would be able to access it. And sure enough, we have the Terraform backend that we are able to create, given that we have a backend specified as S3. We specify that the TF state is directly within the root of that S3 bucket, and the region is equal to US East 1. And now we're going to go just a little bit beyond the basics of Terraform. There is the concept specifically within Terraform that we can do this thing called locals. Locals are kind of what they can be compared to local variables, in that we can specify these. Sure enough, we have a repositories, what is called a collection in HCL, but can be compared to an array in JavaScript. And it can be used to create dynamic variables throughout. So if we put on our problem-solving hat, we could see a time in which we could use this repositories array to be able to create a list of all of our different repositories. And if a user needs a new repository that has a build spec YAML file to be used in code builds, perhaps even a GitHub URL to be able to pull these down, and we'll get into that a little bit later. And sure enough, we can use these locals, and these locals can be passed down to data, in which we would use this data parameter to go and access the specific resources within this repo. Outputs currently within the Terraform platform are a little interesting in the fact that we did find this when we were creating things. If you create an output, the output does not always change with the resource. You have to run something called Terraform refresh, which will actually refresh the output of that specific value. Output should be used on variables you might want to access after the apply and be used. This can be an ID of a resource or other things along those lines. And one of the cooler parts that I think comes with the HCL language that you don't necessarily get with those cloud providers out there using a form of YAML is it comes with a multitude of different kinds of functions that modify the state when we go to create these resources. These can also be used to create loops, which Terraform does its own little workaround to create these different loops. And we can actually take these things and functions and modules. And I'm getting completely rejected by Terraform right now, which I apologize for, but I think it is worth showing that this repo is fully available on GitHub for those of you that want to clone it down and run it on your own environments. It will, in fact, work there. So we can see here that we have a main.tf. Index is the more common thing within the web world in terms of being the root folder. Terraform uses main. And these are just a few different examples that I want to show in terms of these being different methods that we can use in order to make our Terraform files a lot more dynamic. So in here we have the length of var.repos. We'll get into variables in a second. The lookup command will actually go to that specific variable and go and pull the element. And then we can also go and get both that element name here and the element name here. This would be essentially the same approach that we would get in a programming language in which we need to refer to objects. we will set all of these default branches to master. So sure enough, in code commit, we're able to access that code tools module specifically through the source. And we are going to pass it local.repositories. And the role that we have associated with it is the im role.tf demo code build name, which is indicated by the resource above, in which the build does have full access to be able to assume a role within STS. And all of these repositories will be here. So if the user wanted to go and add another repository, they could in fact just add another object here, and they would get every repository within this specific array would go and get its own code build project, code commit repository, a code build webhook. So now you can start seeing that we now have an array, and every single point within that array is able to every point within that array is fully able to go and get its own specific code build project and code commit repository. So if we wanted to, we could go and commit, we could go and create a code pipeline that the repo would also get, given that we have access to the code commit repository and the code build project. So this becomes extremely scalable, which is why, sure enough, code tools right now is its own form of module that we can do here. So a module becomes a collection of different resources that are called upon through this module indicator down here. Continuous integration. So there's commonly this thing within IT, and especially as 2019 starts to sort of wind away from us, the theory of continuous integration is sort of what I was talking about earlier, in terms of we want to make small changes to our infrastructure going forward. It has to be fast, it has to be scalable, especially with the rise of Docker and things along those lines. The theory of microservices and the ability to run these different microservices such that we can actually iterate upon our product as fast as possible screams continuous integration. And that part actually might work during this talk, which I'm really hoping it will. But the big thing is that we can actually run Terraform specifically within continuous integration. And aware that IT always has its own specific buzzwords, but I'm willing to show you that within the proper configuration that we are able to actually get continuous integration, specifically developing on this repo that I've given you all today. So within the CI pipeline, sure enough, within code tools, each repository within code tools got its own code commit repository and code build project and code build webhook. So each of these different things create each of their own specific resources. It was able to look up the GitHub URL. Sure enough, the nice thing about code build projects is that we can in fact specify GitHub as a source for our code. If we go back to global, which we don't want, we want to do services. Code build. I made these back home. Good old Northern Virginia area. And sure enough, we have this TF Talk repo. And this TF Talk repo, which I created prior to our little chat here, just goes to show you how live coding goes. We have a TF Talk repo that is fully enabled, that we were able to build specifically through not sitting here and clicking, but within the actual, by using the local repositories array, we have a TF Talk repo that was created from here using the module from code builds, which was exported from here. Sure enough, this is all part of the exact repo itself. And you can imagine a time where you might clone down this repo and be able to build all of your certain Terraform resources directly within, maybe not O1, the lab with solved and unsolved, because unsolved isn't working right now anyway. But a time in which you could clone down this repo, create all your resources with their own TF files down here, and then just be able to have that code build resource be able to have access to do its own creations and things along those lines, which is another thing that, sure enough, we can Terraform as well. Very simple code build for those of you who haven't used it before. YAML again, which 61F doesn't as to if you're a fan or not. It goes and grabs Terraform. It will go and use 12.14. It will then go and create the Terraform specified command to go do it. Go into, currently mine goes into the one solved, runs a Terraform init and Terraform plan and Terraform apply. Now, the question now becomes, what are these extra arguments? We didn't get to use these earlier. And the reason why is because this is running on a remote, because this is running specifically remote, there is no ability to track who the user is. And there's also a different ability, because we're running on this on a machine, and we would optimally probably want this process to be completely automated. Per se, maybe it's in a build machine such along a build machine like this, in which maybe we run a webhook when a user goes in upon the merge to a master branch. We're able to go and then run the multiple Terraform plans. Terraform will then go and plan and create all of these specific resources. And then it will go and then run Terraform apply with the Terraform plan file that we have created in the last step. And sure enough, if you want to really be nice to yourself, because we all know how many times terminals can actually yell at us, you might as well tell yourself that you have in fact nailed it. This could be a specific use case in which we no longer want to become that DBA or that systems architect that everyone's afraid to go do. We want to create that ability for users and developers to be able to go and create their own pull requests, learn a specific language. Ops is in charge of only really approving the pull request, but they're not necessarily that guy that you have to go and make a ticket and then we nail you with 100 different questions. Our ops team in Indigo is very much along the lines of, we give the developer all the tools that they need to be able to work with what they want to, and ops just kind of sits in the middle to make sure that they build what they're able to build what they need to. So the inevitable question that comes up, aware that, I don't know, React is the more popular front-end tools, and my mind's in the front-end side of things because I'm going to go teach it here in a few minutes. But you know, there are these new shiny tools that all come up, and us as engineers kind of jump into them head on, and maybe sometimes IT managers aren't maybe the biggest fan of it, or maybe it needs a little more convincing. So the conversation kind of ends up like this. Which is why Terraform has a cool thing called Terraform import. Currently, the feature of is the implementation that Terraform allows us to do. Terraform import gives the user the ability to take resources that might already be implemented manually and use Terraform import to be able to take that resource and apply all of its configurations to a file. Now, the only thing that's not fully supported right now by Terraform is the automatic ability for, if we were to implement it, As I get that out of there. If we were able to implement it, it wouldn't naturally write its own .tf file. It would automatically write to a tf state file, in which it would be our job currently to go into that state file, pull all of the exact parameters from that state file, put it into its own resource, and then make sure that the next time we run a Terraform plan, that there are no changes that Terraform has to make. Because once a resource is fully managed by Terraform, if Terraform sees any changes throughout the different resources, it will blow them away, which is a good thing on the operation side of things, but it's a bad thing if that's necessary. That can also have its own capabilities, as it is a naturally destructive behavior. So I think the biggest thing that I wanted to do here, besides show you guys some actual Terraform implementations, which unfortunately I'll have to do a little bit of troubleshooting. But the topics for conversation that I really want to start having people talk about is Terraform is a perfect tool that we've kind of shown here that has all of the necessary implementations with the exception of this one little S3 bucket. But let's imagine like different places in which we could possibly use Terraform. We can implement Terraform within, if we wanted to implement Terraform within multiple accounts. We could just create the Terraform block, much like I've done here, which now I think that's probably one of my issues, in which all we have to do necessarily is switch this specific provider and go from there. If all of a sudden we want to have the exact same infrastructure in terms of disaster recovery within one account, and all of a sudden we want to move all of that stuff to a second account, maybe with slightly different parameters, we now have the disaster recovery. And instead of creating our own migration services and things along those lines, we just use Terraform with the new specified region within the provider, and we're off and running with Terraform apply. I've shown here today that if developers need exact stacks, we can use that locals repository variable to be able to create an array of different repositories and let a developer go create their own repository with the specified URL, its own description, and things along those lines, any parameters that they necessarily want within something like this, and allow them to be able to get an exact stack. Now they're somewhat within the architectural decision, and they're also we're also fully able to make sure that as an operation side of things, we are able to support all of those developers across the board, because we know that their architecture has been fully created. We know exactly how it was created, and we can actually support different things if something were to go wrong. We've recently had certain things in which maybe you get something within an organization in which the worst part, having to upgrade a specific dependency that maybe ops has created for you. I know that there are a few things specifically within our build that we build specific packages for people to be able to pull down. If we want to inevitably be able to go and rerun those, we can do that all within Terraform. And with about less than 15 minutes to go, I will take any questions if anyone really has any available. Cool. Thanks a lot.
Right. Thank you so much, Jason. That was a really interesting session. And We will
I
be
kind
posting it on YouTube and share it with the team and our customers as well.
Yeah, sounds great. If you would share me the repo, I would. If you share me the link, I'd love to actually get this working for you all. That'd be great.
Sure, sure.
Sweet, greatly appreciated, and thanks
Thank
for
you.
your time.
Thank you. You had a great one.